Hey guys, Jim Vanosky with Manufacturing Talks. Welcome back. Not a big introduction required today. I've got Mark P. Mills back. He is now Executive Director of the National Center for Energy Analytics, an organization he put together, and he's always informative and fun. And today is going to be no different. Mark's with us here in just a few seconds on Manufacturing Talks. Stay tuned.
Welcome to Manufacturing Talks with Jim Vanosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Welcome back to Manufacturing Talks, everyone. I am Jim Vanosky, your host, and as always, it is a true delight to have Mark P. Mills with us. He is now the Executive Director for the National Center for Energy Analytics. Welcome back, Mark.
Great to be back. Great to be back. Thanks.
It's great to have you back. There's so much to talk about here. You know, a lot of it's depressing, but you always bring that positivity and
Well, the world can be depressing because
yeah.
between.
So let's dive right in. You know, you've got this new center that you put together, which is marvelous. I see you're bringing some great people on board, and just give us an update on that.
Yeah, you know, there's lots of people who dabble in energy. It's a hot topic now for obvious reasons. It's the biggest single locus of government spending in arguably in history, except for World War II. So we have this massive political issue around energy. We have impossible to avoid the fact that energy is essential. It's like food and breathing. You can't operate
Right.
without it, so it matters. And there are scholars in universities, there are think tanks that have energy scholars, but there are very few energy think tanks. There are a couple in the United States, but they're small. So we, with some sponsors, especially at the Texas Public Policy Foundation, is sort of the anchor sponsor, launched this new national energy think tank. So we have an army of 10 scholars. We have 8 great advisors. People can find it by going to energyanalytics.org or just type in National Center for Energy Analytics. If the Google algorithm is working and hasn't suppressed us, you'll get to us at the top. Energy, and a think tank focus on energy first, and then derivatively the implications for environment, for politics, for economics, everything requires energy. You could study energy by being a geopolitical analyst and worry about oil flows. You could study energy if you're an environmentalist that worries about carbon dioxide, and then go backdoor into how you make energy without emitting CO2, which, by the way, you can't. All energy forms emits somewhere. But what we've done, we reverse it. I mean, we begin with energy first because nothing is possible without energy. And then from there, you can look at, well, how do you make cryptocurrencies? You need energy. How do you produce food? You need energy. How do you make cars? You need energy. And so the energetics either always matter. In a perfect world, and this is why the original book I wrote with my colleague who sadly died a couple of years ago, the subtitle, we had The Twilight of Fuel as this language in the subtitle. And people would say to us, what do you mean by the twilight of fuel? Is that really what we meant was that you shouldn't be thinking about, it should be in the twilight of everyday concerns. You should increasingly be thinking less and less about energy. In a perfect world, it's always available, it's low cost and highly reliable. And you shouldn't have to think about it. That's perfect. It's like, most people in the wealthy West don't think about whether they can eat or not. Most.
Right.
We don't worry about food. We don't worry about water. We don't worry about breathing. We shouldn't have to worry about energy. But now we are. And so
well, not enough people are, I would submit, but I think we're all going to get there here pretty quick based on the current trends. What are the big focus areas as you get this thing out of the gates?
Well, I think we're going to look, initially we did, our first study was on the infrastructure required to make electric vehicles possible. Not how much energy they use, not the infamous charging stations, because they got a lot of news about the billions spent in a half dozen built so far, the government's expense. And not whether EVs are good, bad, or indifferent. I mean, that's a different issue. It's if to fuel a conventional vehicle, you obviously need oil and gasoline, and you have to have a fuel station. But the invisible thing that matters is the vast network of pipes, tanks, and pumps to get the fuel from where it's produced to where. So pipes, tanks, trucks, and pumps. In the electric world, there's a similar network of wires and transformers and conversion systems, power electronics. There's this massive intermediate infrastructure, and that gets ignored. And so that study is about what that would cost to scale to the same level as the gasoline. By the way, the bottom line is $3 to $4 trillion of uncounted money have to be deployed on hardware, not to produce electricity, but to get it to where the chargers can use it for you and me.
Right. Yeah.
The next study we got coming out is on, we're going to do a study on LNG. We'll be looking at the data center energy demand. We'll be looking at the future of oil and gas production in the shale fields of America. Probably look at cryptocurrency, energy, Bitcoin mining. It's a big energy consumer. But all of it from what I would hope, it sort of has been the signature of my work, is sort of a novel way of looking at it, but also a rational data science-based way of looking at it, not the aspirational, we have to do this, but what can you do and what can't you do? And what are the consequences of trying?
Yeah. And the trade-offs, I'm guessing, right?
Always about trade-offs. That's life, right?
Which unfortunately we don't want to talk about anymore. We're just going to do all this stuff and it's all just create the money to do it, which is disastrous. Okay. So, before we got on, we mentioned, as we were chatting, there are some new regulations coming down from the SEC. So let's chat about that.
Well, our next study, which will be coming out next week, is on this specific new SEC regulations, Securities and Exchange Commission, which is intended to require all businesses to disclose their climate risk. So, if you're just sort of surfing across the top of issues, you'd say, well, it's always nice to have disclosures about that. The more information is always better, right? And when it comes to securities laws, you want to know what the companies you're investing in. These are public companies. They're required to make disclosures about big things and legal things and laws and regulations. But the problem with this is, first off, nothing's free, right? The old adage, no free lunch. So if you ask somebody to do something, you're the government, you as a citizen have to file tax returns. That has a cost in your time or dollars to hire an accountant. Corporations have costs in doing disclosures. So we should be honest about what that would cost to do what the SEC is asking. By the way, what the SEC is asking is a cereal producer to know how much natural gas is used to make the fertilizer somewhere remotely upstream from the Cheerios.
Right.
Now, in theory, you could figure that out, in theory, although it gets squishier the further you go down these supply chains. What it would require is that we're zooming right now, and the microprocessors used to make this possible use energy, and the manufacturers of those microprocessors will have to disclose who's doing what, not just by themselves, ultimately, not what energy they use, therefore their quote climate impact, but what their suppliers use, and the trucks that deliver the stuff, and the people that do the mining upstream.
Yep. Did you know, by the way, that I used to make Cheerios? I worked for General Mills for better part of 16 years. So that's a good example.
Who doesn't love Cheerios? Because Cheerios are
absolutely.
First, I like Cheerios. Our grandchildren really like Cheerios. And Cheerios are the go-to, the perfect handful of food you can put on the tray behind you in the car, which keeps a toddler happy.
But they're not cheap, right?
They got expensive, and if you follow the supply chains, we know why. But anyway, there's a cost.
Layer on these regulatory burdens, they only get more expensive.
They cost more. Now, our study is not looking at the economic costs. Paul Tice, who's authored it, is looking at a different sort of macro cost to the securities and financial health of the United States. Others have looked at that. It's billions and billions of dollars of compliance requirements, and those billions of dollars, you say, oh, the businesses pay for it. No, they don't. If General Mills has to pay for those compliance costs, they have to end up showing up in the cost of Cheerios. So it increases the cost of goods. And say, well, but it's for a public good. We're exposing this. Well, that's not the job of the Securities and Exchange Commission. Their job is to make sure financial markets are operated legally and safely for investors to know when they buy a stock in a company, the company is not run by crooks or doing things that violate laws. If Congress wants to pass a law that says you can't use oil, Congress can do that. Congress can do really dumb things, has done dumb things. That'd be
And
really
they do
dumb.
all the time, right?
And they would probably have a political consequence.
Yeah.
Congress can ban things. Governments can do stuff, but doing it backdoor by these and this is what's going on with the climate debates, is all kinds of rules, mandates, cloaked in what sounds like okay language, are being used to force behavior changes that really belong in the purview of Congress to say, if we don't like the fact we're using hydrocarbons and we think we should stop, then you can pass a law. Now, one of the laws that's been passed is the Inflation Reduction Act, which is effectively to subsidize the competition, or EVs, wind and solar,
Yep.
and also to increase regulations and disincentivize the use of oil, gas, and coal. Okay, law got passed. It's there. We should talk about it. We have talked about it, about what it really costs, what it will do. But ultimately, the point I've made many times in Paul's papers about securities, the problem with that is it will make securities less transparent. It will make the United States less competitive. It'll make things more expensive here and advantage other countries, not to mention it's actually arguably a violation of the enacting law under which the Securities and Exchange Commission operates. So there are lawsuits, and there will be more lawsuits, essentially saying the SEC can't do that. I think those laws, I'm not a lawyer, I think those lawsuits will ultimately prevail, but they could put the rule in place in the meantime, and you have to wait and see if a judge will stay the law. That's the game that's playing out. What Paul is going to do, Paul Tice, my colleague and our senior fellow, is pointing out what the stakes are. Yeah, what the stakes are. What I pointed out is something that it's just a simple fact, and this is true for Cheerios and cars. And by cars, I mean Teslas. So whether you whatever cereal you like, and whatever claims are made about net zero and reducing carbon footprint, we have a simple fact: 100% of all products and services, not some ratio, but every product and service in America, in fact, in the world, requires the consumption and production of hydrocarbons. Not some, all. The amount of hydrocarbons, whether it's oil, gas, or coal, and the amounts vary depending on the thing, but there's nothing that exists that we can build or operate without using hydrocarbons. So even though when you do the PowerPoint presentation, which we've all seen if you're an energy follower, that roughly 80%, north of 80% of America and the world's energy, primary energy, is oil, gas, and coal. That's misleading. That's just true. It's the primary energy. So if you parse it out that way, but in terms of functional stuff, you can't make batteries without burning oil and natural gas, and coal. You can't make you can't make Cheerios. Oil, gas, and coal are used somewhere in a supply chain. Coal is used to make steel. Coal is used to make aluminum primarily these days because China produces the majority of the world's aluminum. Natural gas is used to make glass, so it means it's used in solar panels. The supply chains are all anchored in hydrocarbons, not to mention polymers and plastics, which are used in everything, not some things, from medical products to the packaging of Cheerios. Everything has polymers and hydrocarbons involved. So the aspiration to get rid of that means that you're making a astonishingly fundamental shift in the operation of civilization. I would say, first of all, that'll have a cost, but more importantly, even if you thought it had to be done, it should be done, it won't be easy. It'll take a very, very, very long time, not decades.
So you're saying we're not going to get there by 2035? That's a leading question.
By 2135. That's what I would
say.
But
yeah.
Not be around to prove that, but we could put a time capsule bet, bury it in the ground.
The prediction. All fascinating stuff that we're not talking about near enough. And another piece that I think, from my particular world that I keep trying to get attention on and seem to constantly fail is, you've talked about just the broad effect, and I'm focused on manufacturing, and even without this SEC stuff right now, I'm looking at the regs that are in place and that we're working against, and I see American deindustrialization is inevitable?
Well, I'll take a different spin.
Okay.
The risk of deindustrialization is high. The inevitability is a political question. So, and deindustrialization is being driven by two related vectors, as you know. One is just the sheer magnitude of regulatory compliance,
Right.
and as you know, the tracking of this is done by the manufacturing, the trade association, I'm just having a neural synaptic failure, or what are our friends called?
Yeah.
My friends. So the trade association that tracks manufacturing in general, or manufacturing trade association, tracks every 2 years. I think is this a biannual report on regulatory compliance costs. Last year, or I think it was earlier this year, they released it. So the average cost to comply with regulations in the United States for a manufacturing firm is $15,000 per year per employee, I think is the number, for a large firm. For a small firm, it's $30,000 per year per employee. So your spending as a small business, and manufacturing, as you know, it's dominated by small businesses. Small to mid-sized enterprises are overwhelming the employers and overwhelming the share of the total manufacturing economy. So imagine you're the employer, you have a small mid-sized business, and whatever you pay your employee, you also have an overhead cost of $30,000 per year, not taxes, but a regulatory tax, compliance costs. This is a lot. Now, if you compare that to China or Indonesia or we know that they have regulations too, but their compliance costs are about that. So set aside this claim that our cost of labor is driving things overseas is not true. It's our compliance costs, in my opinion, are driving things overseas. So that's the first order, and that's been going on for years and getting worse. And until that's taken seriously, then you can't give a business enough incentives. Well, you could say, well, refund every dollar of compliance cost you have. That'd be $30,000 per employee per year.
Right.
That's not going to happen politically. It would be cheaper just to rein in the regulations, not get rid of them, make it more rational. The other cost, of course, is energy. Manufacturing is energy intensive. So manufacturing pharmaceuticals, manufacturing Cheerios, manufacturing batteries. This is the most energy intensive part of our economy. If you increase the cost of energy, you again disadvantage the manufacturer. So what you have has happened. Our poster child for this is Germany. So Germany's cost of energy, electricity, is tripled. The government there has tried to insulate its industrial sector from that by giving them subsidies or guaranteeing them low rate, subsidizing it. But that's can only go on for so long, and it's failing. So Germany's manufacturing output is down, I think, close to 20% over the last 4 or 5 years.
Right.
Germany's attracted deindustrializing, not because of regulations. They have regulations that are less onerous than ours, but they're real. But because of their abuse of energy costs. So the U.S. still enjoys the cheapest energy for a large industrial economy on the planet. Just full stop. That's where we are. We have one of the highest regulatory compliance costs, but we get to offset that with cheap energy. I'm being simplistic, but that's roughly where we are.
Sure.
I think, but what we're doing now is moving the United States towards more expensive energy. If these so-called transition plans actually get implemented, that will cause a deindustrialization of the United States. That's where you and I agree. We have not increased our industrial output by an amount equal to keeping our share of global manufacturing, but we haven't had an absolute contraction in our manufacturing economy. It's roughly the same size as 20 years ago, but it should have been bigger. The world's bigger. We lost market share. So now we have this reshoring mania. Let's bring chip fabs back. Let's bring pharmaceutical manufacturing back. Let's bring food manufacturing back. We worry about safety, and we should worry about food safety. We should worry about battery safety. We should worry. These things matter. That means you're going to, per dollar of GDP produced, brought back. The good thing is manufacturing has the highest economic spillover effect, as you know, of any part of the economy. The jobs created and the wealth created and the salary in the jobs is higher in manufacturing by a factor of 50% to 2x compared to the services sector. So great, bring it back. But the energy intensity is twice as high as the service sector.
Yep.
So every dollar of GDP you bring back is a wonderful thing geopolitically and socially, and for jobs, and for high-paying jobs, but it also increases energy demand. And this is the collision that's now happening, that's especially on the electric side, that's being quasi-ignored. It's not being totally ignored. I testified before a Senate hearing in late May before the summer on exactly this issue, that everybody's acting shocked that electric cars, manufacturing them here, chip fabs, and of course data centers now are in the news, use electricity. Who knew? I mean, what a shock.
Yeah, shocker.
We built lots of them. They're going to need a lot more electricity than we planned to supply. And if we supply with wind and solar, the electricity will be too expensive and too unreliable to run 24/7 facilities.
Yeah. And that's a piece I've focused on pretty heavily is, just with the EPA's moves and individual state regulations around this supposed transition, we're shutting down our coal plants and supposedly replacing them with all the intermittent renewables. But the trouble is those intermittent renewables are intermittent. And so manufacturing uniquely relies on both affordable energy and reliable energy. And so we're attacking both of those legs of the stool, bad enough to lose one leg of the three-legged stool. You lose two, you're really flat on the ground, aren't you?
You lose them simultaneously. The demand shifting, load shifting is possible with services and some, residential behaviors. Dry your clothes off peak, right? But if you're running a commercial kiln dryer to dry something in an industrial process, you can't shift that around. You can ramp down the operation and not operate. Some things can be slowed down. Some things can't. Certain kinds of industrial processes, as you know, like glass production and steel production, the furnaces run 24/7. And when you shut them down, they're shut down forever. They become garbage and you build a machine.
Yep.
So the response to what you just said, and you've heard over and over again, is, Jim, come on, is the exponential decline in battery costs. We're building more grid scale batteries than ever before. And the way you solve the intermittency problem is you build batteries. Well, that's true. You can build batteries, but it's like everything else. You got to be honest about the cost and timelines and scales. So let's use, just as an example for calibration purposes, I'll use future expected costs for grid scale batteries, not today's costs, future expected, which won't happen because batteries are getting more expensive now, not cheaper because of input costs. But let's assume it does. Assume it does. Let's look at future costs for batteries and ask this question. In an industrial economy like ours, we store energy for the purposes of reliability. At a macro level, what that means is we store roughly a month's worth of demand to 2 months worth of demand of both coal, oil, and natural gas, or gasoline or diesel fuels. That's roughly what the storage level is. You store it by the month, not the hour, so that you have optionality, price controls, reliability. And this is how industries operate too. You don't run everything on just in time, especially with energy. In the electricity world, U.S. electricity supply, if we wanted to store 1 day, let's just do 1 day, not 1 week, 1 day's worth of U.S. electricity, on the assumption that the entire grid is running on wind and solar, which is the aspiration of the energy transitionists. So it's an all wind solar grid. And for 1 day, the entire continent is becalmed, which has happened meteorologically all the time. And the entire continent is under cloud cover, which also happens meteorologically regularly. And they both happen simultaneously regularly over decades. So 1 day of U.S. electricity stored in the future cheap batteries is $4 trillion of batteries. All right, so let's pretend it gets even cheaper. It's just $1 trillion for a day, but a day is not enough. We store stuff by the weeks and months. So let's go for the 10 days instead of, so we're now back to $10 trillion. These are staggeringly unachievable numbers of capital to be deployed to do what we already do today. Oh, let me calibrate that for the electric sector. The way we deal with reliability and electricity is we store fuel, we don't store electricity, and we build excess electric generating capacity, which has a cost. Well, this is arithmetic. How much does that cost? Well, storing oil, gas, and coal is really cheap. It's roughly 100 times cheaper per unit of energy than batteries. That's because you put oil in a barrel, and the barrel's cheap. It's just steel. You put gas in a cavern below, below ground that already exists, or you can put it in a tank. Coal is just a big pile. So self-evidently,
Right.
storing energy is cheap. The cost in backup electricity is you have to build more generating capacity than you otherwise would need to have it ready to use on demand when that cheap stored energy. So just calibration point, the United States today has about $200 billion of capital investment in more generating capacity than you need on any average minute. So that at the on average minute, you have what you need. So that's your cost. Your reliability cost in capital terms is about, call it $250 billion to run power plants that can run for weeks. For $1 trillion, I can store enough electricity to run for a day. So this is not a good bargain. And as I've said many times, this is not going to happen because it's
exactly.
it's just nuts.
But we can do a lot of damage in the meantime trying to make it happen.
We are,
unfortunately.
and we can, and we are. And this is where, and what's happened is Europe's tried to do this. Germany, they'll go back to Germany. But the trying to do this has resulted in Germany having its electric costs triple, its industrial sector shrink by 20%, and a political revolt internally and a geopolitical exposure. So they are further down the path that we're now going to try. It's my personal guess that the U.S. electorate won't like that.
Right.
I don't know why the Germans put up with it. I don't understand the psychology, but they have up until now. I don't think they're going to keep putting up with it. There's a lot of reversals happening quietly in Europe along these plans. I think they'll happen here. So that's why you said we're deindustrializing. I would say we've been damaging our industrial capacity with punitive regulations, excessive regulations, and not damaging it in energy terms. You're right that if we damage it in both terms, we will deindustrialize. The industrial capacity of the world will accelerate offshore. If we want to bring industry back, which I'm a huge fan of doing, what I'm not a fan of doing is cherry picking who I want to bring back by saying, "Oh,
Absolutely.
I want Cheerio manufacturing here, but I don't want that kind of car combustion car manufacturing. I don't want. I want electric car manufacturing." It's like saying, "I want Cheerios, not bran flakes, to be manufactured." Slightly hyperbolic, but that's the equivalent choice. If you want more manufacturing, you create the conditions for which manufacturers and the market will say, "I can make money manufacturing more Cheerios or cars." But those conditions are, right? We know what they are. Fundamentally, make it a friendly place to invest your capital. The old adage, capital goes to where it's treated well. So capital involves punitive regulations and punitive financial markets. You don't want that, which includes taxes, by the way.
Right.
You want lower industrial taxes because taxing an industry is just taxing people. It's a shadow tax. Said it over and over again. There should be zero tax on manufacturers and industrial sector, in my opinion, zero. Why are we taxing? You're taxing people. Now, the reason we're doing is because it's an easier way to tax a citizen than saying, "I'm going to raise your personal taxes." The money's got to come from somewhere. So I'll take it from the cereal maker. That raises the cost of cereal. Has to.
Yep.
And so, it's politically, I get why it's happened, and I'm not naive. We're not going to have zero manufacturing tax, but it should go down, not up. And the goal is to, tax those evil rich corporations more. It's really, really bad idea.
Agreed.
So you should have friendly capital environment, friendly regulatory environment, and a friendly energy environment. On a macro basis, if we had to have an industrial policy, quote unquote, and I'm not a fan of industrial policy, I'm a fan of industrial goals. Policies supporting those goals are those three. Now, do we have enough labor, skilled labor? Nope. How do you get that back? Same answer, right? Create the conditions for which the manufacturing sector and industrial sector can get the labor they need. My opinion on that. That's going to be increasingly with automation, so that those who have the skills will be paid more to manage the now more complex automated environments. So it's a win-win-win. We'll produce lower cost goods domestically with higher paid domestic labor.
Yep.
We're not going to suddenly have more massive influx of manufacturing jobs. We don't have the people, and nor is that the economically sensible way to do it.
Agreed. Now, you just touched on something I definitely wanted to hit before we wrap up, and we are almost out of time here. We agree violently on the way to move forward in our manufacturing is greater automation, higher level jobs for everybody. You're a big fan of humanoid robots, and I'm actually not. So tell me why.
You know, when we say robot, everybody thinks about the anthropomorphic, the humanoid robots, because
for sure. Yep.
I mean, they first imaginations of an anthropomorphic robot are in Greek mythology and the Jason and the Argonauts. That's where it began. It's a really, really old idea, making automatons. It's really hard to make an automaton. Nature's been really, really good at making anthropomorphoids. Us.
Yeah.
It's just technically very, really hard. Not navigation, power systems, compliance, not injuring. Anyway.
Yep.
Robots, you know, a PLC, a programmable logical controller, or PLC, is a form of a mini robot controlling. I mean, the first steam engines had to have equivalent of a thermomechanical PLC to regulate steam so the boiler didn't blow up. We've been adding automation to things for a long, long time, and the modern word for that is it's a robot. But what we all know we mean by robot is it's a humanoid robot that can walk in our environment. But the robotics began before that. Robotics is mostly non-humanoid robots.
Yep.
So, but the reason I think, first of all, I would say two things about robots, humanoid robots. The Terminator robot, great fun, science fiction, science fiction, comic book stuff. Yeah. There's no rise of the machines taking over us. It's silly. Great fiction. I love the fiction. I aspire to write a book about humanoid robots doing bad things and good things. Isaac Asimov wrote the iconic books on that, the trilogy on iRobot.
Yep.
Made it into a lousy movie, but still fun for a big movie. So I would say, as I put in my book, the reason I'm saying humanoid robots are coming is, and you can make technology forecasts by doing what I did in my book. You forecast what's already happened. So technologies that have been invented some time ago that are on cusp of commercialization, that is just being commercialized or about to be commercialized, that have spent decades in development, that are not widely used, are easy to forecast. We'll use more of them. How much more and how fast is a more difficult, guess. But the more and more, the more is easy to predict. I predicted a lot more AI in my book, and the book was published about 2-3 months before ChatGPT came on the market. It's not because all of us who study this knew AI was being used widely and was about to take off more widely, and it did, but that was predictable. Sure. Yeah. So there's about 24 companies at various stages making commercial humanoid robots right now. I would say there's a dozen leaders. Of those dozen leaders, 8 are US companies, 4 are not. One is Chinese, one's Swiss, I think one's Norwegian. I've lost track of them all. But anyway, and all of them, including one of them is Tesla. Elon Musk, typical of him, called his robot Optimus, of course, out of the Transformer land of movie and science fiction comic books. So these are not lab experiment robots. Boston Dynamics is the most popularly known on the YouTube channels. For sure. These are not laboratory toys. They're not university projects. Every one of these dozen are designing and manufacturing at pilot scale. In one case, beginning Agility Robotics, now making a commercial humanoid robot. Mm-hmm. So we know that they're real because they're being built. We know they're being used. Some are being bought. So it's no longer a dispute that humanoid robots are possible and that they can be built. The real question now is, what utility do they have, and where will they be used, and why would I want one? So the two are the same. Why would I want one, and where will it be used? So most automation, especially doing motion, welding, cutting, drilling, holding, assembling, humans are really good at that, and the machines can be good at repetitive tasks. Non-repetitive task machines are lousy at. So in the manufacturing sector, it bifurcates almost perfectly. 90% of all the robots in the manufacturing are in 10% of the companies. The really big ones doing high volume repetitive tasks. 90% of manufacturing, roughly speaking, is in the small, medium-sized business by dollar labor measure, maybe it's 80%, where only 1% of robots exist. Manufacturing is unrobotified because most of the tasks in those small, mid-sized businesses vary. They're small batch. They require being next to a human constantly. So you first, in order for automation, robots to operate with humans, they have to work in the human environment. The only way you can work in a human environment is if you can operate the way humans operate, step over ledges, open doors, valves, and not injure humans. That's why robots in a lot of high-speed automation are in cages, locked up, because they move fast, repetitively, and don't notice things because they're stupid. They're not smart robots, and they would kill a human in that cage. So for the technological challenges of being able to work alongside a human are extraordinarily hard with humans. Never mind with robots. Humans don't always behave.
As I well know.
But we're there. So where would you do that? Well, warehouses. The first application, which is you do the easy, low-hanging fruit. So warehouses are critical to the supply chain. The Agility Dynamics went to UPS and Amazon to look at where they have a labor problem that might be solved by a robot, a humanoid robot. I mean, not where do you shove the robot in, but one of the labor problems they have is the bins that move around on conveyors when they're empty, when the human and sometimes a robot does the picking and sorting and packaging. There's an empty bin. It has to be put somewhere. And typically where it has to go can't go on a conveyor. It varies where it has to go. So a human being has to pick it up depending on the day and hour and move an empty bin. And it consumes a human's time. So the task, in effect, I'm simplifying what they were doing. If a humanoid robot could do that task, that humanoid robot, if it's cheap enough, frees up the human to do the more valuable task. And that's a perfect application because you can't be done easily with a wheeled bot. It could be. Boston Dynamics done a wheel one does a similar thing. It can't be done with something bolted down. So there's lots of use cases like that. The reason the military sponsored the first DARPA contest for humanoid robots was for firefighting on ships in confined spaces. So if you want to do firefighting on a ship, the firefighter is a person, really, really high risk thing to get the hoses to the front of the fire. But you have to be able to navigate where humans navigate, step over high thresholds, open valves. So that's why the contest, if you go back and look at the original DARPA humanoid robot contest, it was to walk upstairs, open a door, turn a valve, right? Very simple things that humans can do in their sleep. Robots can now do that. Yeah. That's where you'd want a robot. I'd rather have a robot firefighter to go in before the human than the human. And so there's all kinds of use cases like that, which are easy to see. And then as the robots get better and cheaper, then the use cases expand. So that's why I say it's going to happen. And that's why I'm a fan, because economically it's a good thing. Automation, when it's affordable, is always a productivity boost. But I would put it in the moral case, because the first place we're going to use robots as in either really boring tasks or really dangerous tasks.
Yes. Dirty, dark. Yeah. All the stuff.
Why do you like? Why don't you like my
I'm coming from the industrial world where we've already developed many robots over the years, starting back in the late 1950s. And what we did is transition the tasks to make the robot the most sensible for the technology. In other words, rather than mimicking what the human was doing, we redesigned the task so that the robot that we could produce at the time could readily do that.
Yeah.
But so just a different angle. But I do understand now what you said, and I wrote it down, that to do a human task, you have to operate like a human. Some of these things you probably can't redesign, like we've done with, for example, palletizing or picking and placing.
Exactly. So your point is what you just described is why robots have not penetrated significantly outside of narrow application. If I'm in the industrial sector and you bring me a new machine and I have to redesign a process or building to accommodate the automation, then the ostensible economic benefit of the automation is wiped out by the cost and time to redesign, rebuild, and retrain the rest of the ecosystem. So in some cases, the automation advantage is so overwhelming that you redesign the process. That happens.
Yep.
That's a minority of cases. And so you've epitomized the problem. When you have somebody's got an anthropomorphic robot, it comes in and you discover using it, or it's Boston Dynamics robotic dog, and they say, well, actually, to use it properly, you're going to have to do all these design changes on your stairs and this. The valves aren't at the right height. You're the operator. You say, okay, get out of here. I mean, I don't have to do that. Time is money.
Yep.
And you don't understand what's going to happen when I change this to that. Everything's connected.
Very good point. Yeah, unintended consequences.
Yeah. So the magic is when the robot can effectively be trained the way you would train a human to put them in that exact unmodified location. And that's a useful robot.
That makes perfect sense. So, I was worried through a lot of this conversation. You historically in our visits have always brought this positivity and optimism. And I thought, gee, we're not going to get there. We got there, and it's in robots.
And we can bring it back to energy. So
yeah,
it takes energy. Robots eat too. They have to consume fuel. And by and large, robots are not going to have an internal combustion engine. Some will, big ones. But most will have batteries. But that means that the robots will use some electricity. Mm-hmm. They're not as energy efficient as humans, by the way, by a factor of maybe 100 worse. So for every kilogram moved in terms of the physics of energy by a robot will consume 50 to 100 times more energy than the human doing it. But you don't have to eat that many Cheerios to lift a 1 kilogram bin. And the energy supply chain is pretty modest. So I'm increasing a small number by a big number, but still a small number. The energy cost of robots is in manufacturing them, just as is the energy cost of computers and computer chips. A robot is a computer with electric motors and a battery, right? And so all those electric motors and batteries and the computing chips consume energy. So the manufacturing of robots will be the primary energy vector, just as the manufacturing of computers is the primary energy vector for most applications of computing. Yep. And it's a net new demand for energy. It's just as computing was. This is so the full virtuous circle comes back to we're using our imagination to do something incredibly difficult. Put a robot to do a human task where a human could go off to do a higher value task that has not just an information component. We have to know enough to do that, to build it, design it. Then we have to use energy and materials to make the machine to do it. That's the story of humanity. And the net is lower cost goods, more safety, greater productivity, and expansion of human flourishing. So all a positive. It ain't the Terminator.
Yep, absolutely. Well put. Well, I have got to get you free. I know you've got places to go and people to see. So, but as always, Mark, just incredibly illuminating and fun to have you here.
Well, it's great to be back on. And I'm glad we brought my world of computers to your world of Cheerios.
For sure. Yeah. Always a pleasure. Thanks to Mark Mills. And of course, as always, thanks to you guys out there. You are why we're here. We're here every Tuesday and now even sometimes on Thursdays. So tune in. We'll always have interesting stuff. It is not going to be as educational and illuminating as what Mark brings. That's an impossible task, but it's all going to be educational and illuminating. So thanks again from Manufacturing Talks. I'm Jim Vinosky. So long.
Thanks for tuning in to Manufacturing Talks with Jim Vinosky. Watch for new episodes dropping every Tuesday. Don't forget to like, share, comment, and subscribe.